The last concept that we're going to talk about in this lesson is nets. What is a net, you ask? It's a two-dimensional diagram that you can fold to form a three-dimensional figure. For example, this diagram is a net. It's comprised of rectangles and squares. Can you imagine cutting it out and folding along the lines? What would you get? I am sitting here imagining this, and I see that this rectangle will be the front, and the rectangle above that will fold down and become the top of a polyhedron. Then we have a left side that will fold back, and then we'll start folding the whole thing under, so that square will be the bottom, and this rectangle sticking off to the side will be the right side. And so our final rectangle will fold up and become the back. Can you imagine folding that all up and coming up with this polyhedron? Notice how I've realigned the words so that you can kind of see how they might go together. So we went from this into this. Can you see it? If not, try doing it yourself. Draw this net on a piece of paper and cut it out, and see if it doesn't fold into this. Let's try this. What solid can be created from the net? Well, the first thing that I see are two circles here. And I'm thinking that they're kind of like the rectangles that were sitting off to the side of that last drawing. So they're probably going to be the left and right sides of whatever happens here. And then this rectangle is going to connect the two of them together. And so I see that rectangle wrapping around and forming something that looks like this, kind of a tube. Can you see how that works? Once again, I encourage you, if you're having a hard time imagining this, draw this figure on a piece of paper and cut it out. Try folding it up to see if it actually does create this net. This time, let's draw the net from the solid. I usually like to start from the front or the bottom. In this case, the bottom seems to be a nice quadrilateral. Remember that we're looking at it from an angle and it's down, and it looks a little strange, but I think that it's probably a square. And so there we have our bottom. Now let's start going around the other faces of the figure. They all seem to be triangles, so here's one triangle. Once again, remember we're looking at it at an angle. So I'm guessing that it will look something like this. Notice it's an isosceles triangle. And then there's the back side that's been folded forward toward me. So I'm going to unfold it, and that will be the back side. Now let's look at the right side here. Again, this is a triangle. You know, it's interesting, this triangle, it's a little bit easier to see that it is an isosceles triangle, isn't it? So that will fold off to the right side of that square. And then we have the front face here. Again, another triangle, so we'll fold it down in front of the square. So we have this wonderful little net here. Once again, notice that there are the four triangles coming off from either side of the bottom of the figure, and they are all triangles. The number of faces in a net should be exactly the same as the number of faces in the solid. Now, interestingly enough, Euler has a formula for two-dimensional figures too, for nets as well. And his formula for 2 dimensions says that the number of faces, and you'll see that there are 5 faces here, plus the number of vertices. Now notice that the vertices have increased. We have the 4 at the tips of each triangle and the 4 at the corners of the square. So that's 8. 5 plus 8, number of faces plus the number of vertices, is going to equal the number of edges plus 1. And you'll notice that we have 4 triangles here. Each triangle has 3 sides, so that's 12 edges plus 1. 5 plus 8 is 13, and 12 plus 1 is 13. Again, that's just something that you can use to make sure that you have included everything in your net.